For those of you who have joined us, we'll go ahead and get started. Welcome to the Rescale webinar, Running LS Dyna on Demand in the Cloud. I'm Sarah Dietz, the Business Development Manager at Rescale, and joining me for this webinar is Moyanto Port, our VP of Engineering. We're about to get started. A couple housekeeping items. We're recording this webinar and we'll be distributing it later this week. If you have any questions during the webinar, please make sure to type them in the questions section of the GoToWebinar panel, and we'll answer these at the end. Here's our agenda for today. I'll do an overview of the Rescale platform and talk a bit about the LSTC and Rescale partnership, as well as the licensing options for LS Dyna on Rescale. I'll then be passing this over to Moyanto, who will be diving into how to run LS Dyna simulations on the platform and showing how to set up, run, monitor, and post-process your LS Dyna jobs on the Rescale platform. We're also going to take a look at some scaling studies we've done. We'll end with some time for questions. Rescale was first started about 5 years ago. Our founders, Joris Poort and Adam McKenzie, both came from Boeing, where they were working on the 787 wing design. It was there that they faced the challenge that many of our customers face in dealing with constrained hardware resources internally and the struggle to get the capacity that they required. They were tasked with figuring out the way to speed up the process. They developed an internal cloud solution to address this issue. It was through this experience and the subsequent understanding of how the public cloud had matured that served as the genesis for Rescale and for a solution that would provide the needed scalability to teams on a global level. Looks like my screen's not sharing. Just 1 second, figuring out the screen. All right, sorry about that. Okay, what Rescale provides is a comprehensive cloud platform for running simulations. There are several components to the platform. The first is a straightforward interface that allows engineers and scientists to set up and execute different types of simulations with an easy-to-use workflow. The next piece of this is with hardware. Rescale is a multi-cloud environment. We partner with several infrastructure providers with over 30 data centers globally, allowing our users to leverage a wide range of different types of hardware, including InfiniBand and GPUs. The next component is software. We support a wide range of different software packages that are pre-installed so our users can have one unified platform from which they can execute all of their different simulation work. In addition to seamlessly submitting their simulations on the platform, users can also monitor their jobs in real time and can do pre- and post-processing directly on the platform. Security is paramount at Rescale, and we have various security measures built into the platform. I'll be coming back to this in just a few minutes. Our admin portal adds another layer of security to the platform and allows IT and management to manage and monitor usage and set additional budgets, permissions, controls within their company accounts. The platform also has the ability to integrate with existing on-premise resources, so IT and management can have transparency and control over the resources being utilized. To dive into the hardware a bit more, as I've said, Rescale has a multi-cloud environment, and these partnerships enable us to offer a wide selection of different hardware configurations. In addition to the 36 global data centers you see here, we also have 4 distinct sites. We have 2 platforms in the US, one of these being for ITAR-controlled work. We also have a dedicated regional platform in Europe, as well as one in Japan. These dedicated sites are for users requiring that their data stay within one region. As I mentioned, security is our top priority. We take it very seriously. We go to great lengths and have many measures in place to ensure that the platform is secure and that our users' information is secure at every step. We go through lengthy and in-depth processes, including an annual audit, to meet strict security compliance and regulation requirements. One of these measures is encryption. Users' data is encrypted both in transit and at rest. And when simulations are running, they're being run on isolated encrypted clusters. We're happy to dive into this more offline to talk in detail about the different security measures we have in place. Our customer base is far-reaching, and the Rescale platform is deployed across a range of different industries, including, not limited to, automotive, aerospace, oil and gas, life science, and academic institutions as well. The type of analysis being done ranges across industries as well. As an example, with our automotive customers, we see a lot of crash and CFD. With aerospace, we'll see dynamic stochastic studies, and with oil and gas, we'll see reservoir simulation. This is just a snapshot of a large Rescale automotive customer who has been running Allustina in the cloud on our platform. This customer was dealing with the frustration of having fixed capacity that wasn't meeting the variable HPC demand they were dealing with. The graph here shows 3 months of usage on Rescale. The fixed line indicates their previous fixed capacity, and the graph shows what they were able to run on Rescale by having access to on-demand scalable resources. With Rescale, they were able to drastically reduce capital expense by shifting from on-premise hardware to scalable cloud resources that they could instantly deploy. Now back to Allustina. We have a strong strategic relationship with LSTC. This partnership enables existing Allustina customers to purchase on-demand Allustina licensing directly on the Rescale platform to instantly scale out their work. We support both the newest and past versions of Allustina on the platform, and if there's ever a version our users want that we don't currently have, the turnaround is quick to get this available. As Moyanto will demonstrate shortly, in addition to our straightforward workflow to kick off your jobs, we also have our desktops feature available for pre and post processing that allows users to open up a remote desktop to visualize their results directly on the platform. Finally, at Rescale, we have a strong support team of CAE and cloud experts who are available to chat live on the platform and help with any of the issues that our users may have. Moyanto will now be taking over for the more technical side of this presentation.
Thank you, Sarah. So, as Sarah mentioned just before, we support many versions of Allustina, including the latest versions. We have over 150 executables installed on our platform right now, covering versions 4.1.2 all the way up to version 8.1. You can even run the latest beta of R9 on Rescale as well. We support SMP, MPP, and hybrid versions when available, as well as single and double precision versions. So if you don't have the version you need, we also support bringing your own version. Often our customers want to run the exact version they are running internally, whether it's a release version or a version specifically or specially built for the customer. So we build a framework for them to upload their version to Rescale and run that version on Rescale without having Rescale install it on the clusters. Lastly, we also support Alice Prepost in batch mode. We support versions 4.0 to 4.3. We use virtual frame buffers to render graphics in memory, so our users can use Alice Prepost to export movies as well as images. So traditionally, users will craft a command to run Allustina with knowledge of their local HPC infrastructure. On Rescale, the environment is often different from our customers' HPC environment, and it may even be different on Rescale itself, depending on what backend hardware you're running on. So for that reason, we provide a simple command line interface. Most jobs can be run using the commands shown here on the slide. So just Allustina-I and then the name of your input file. This will run your job in full MPP mode on the number of cores provisioned on the Rescale platform. It will also run the default position on Rescale, which is single position. The user may optionally choose to pass in the position using the -p flag. You can also specify the number of threads per MPI rank using the -s flag. And you can also tell LSDyna to use any LSDyna specific commands to pass through straight to the LSDyna commands using the -a flag. Lastly, you can also specify the version you want to run if you bring your own version. I will go a little bit more over this command when doing the demo later on. So here is the model that I'll be using for the demo. It's a model of a two-car crash between two Dodge Caravans. So this is a publicly available benchmark problem, and it can be found at topcrunch.org. And so with that, I will go to the demo.
I will make you the presenter. Just give me 1 second.
So when you come to Rescale, you are first presented with the login screen. So here you can log in. So let me log in, Greg. We support both single sign-on as well as multi-factor authentication. So you can use your internal single sign-on provider and multi-factor authentication for extra security. All right, so once you're logged into the platform, you're first presented with a list of your jobs. You can see the status of the jobs, whether they're running or they're completed. You can also see how much storage each job takes on Rescale. So let's go to setting up a job. So on the top left here, we go to new job. This will bring you to the job setup page. The first step of the job setup page is to upload your input files. But before we do that, I'm just going to give this job a name. So I'll call it LSDyna Caravan example job. And now let's upload our input files. So there's two ways of specifying the input files to your job. The first way is to upload them from your computer. The second option is to select them from select existing files from cloud storage if you have uploaded your files before. But in our case, we're going to upload our input. So I've got this mesh input file that I've compressed and a LSDyna key file that I'm going to upload. So once it's uploaded, you can see the status of the upload here in the top. While it's uploading, we can go ahead and continue setting up our job. So next I'll go to the software setup page by clicking on software here on the top. And I can search for software here by typing in the name of the software. And so I'll select LSDyna. And that'll bring you to the software setup page for LSDyna specifically. The first thing we'll do is select a version. So you can see all the versions that are available on Rescale. In this case, I'll select version 8.1 for Platform MPI, and which has also been compiled to utilize AVX2. So like I mentioned before, we can use our command line interface here and just specify the input file here. So like I mentioned before, this will run in MPP mode and in single position. If I would want to run it in double position, I would add something like this to the end of the command. So after we've specified the command, we have to specify our license options. We're going to purchase an on-demand license. You can review the on-demand licensing prices here, which are on a 24-hour basis. So you can see that the more course you run on, the cheaper your license becomes. So now that we've specified our LS-DYNO software settings, we can go ahead and select the hardware. So because I specified the AVX version, we are only showing hardware that supports AVX acceleration, which are, in this case, our Onyx and Titanium core types. For example, if I were to select a non-AVX version, we would be presented with a larger list of core types. And alternatively, if I select an InfiniBand version, we'll be presented with a list of our InfiniBand core types. So let me go back and select the original version that we chose first, and we'll run this on Onyx. And so let's run this on 36 cores. And then we're ready to submit our job. So before I submit the job, let me just recap the steps that we took to set up this job. So first, we gave the job a name. Secondly, we uploaded our input files. Then we set up our software, specified our commands, and selected our license options. And lastly, we selected our hardware. So really, it's just a three-step process of setting up your job. And so now I'm going to submit my job by clicking the Submit button here at the top. And in a few seconds here, we'll be brought to the status page. So the first thing we'll do is validate the job, make sure that the licenses are available, make sure that our command is specified correctly. And then we're going to go and start cluster. Starting a cluster takes anywhere between 2 and 6 minutes. This will provision the hardware as well as bootstrap the software to your cluster. So while we're waiting for the cluster to spin up, I'd like to talk about some of the options available here on the status page. So the first thing is the sharing function that we have built in on the Rescale platform. This can be accessed by clicking the button here at the top right. This will bring up the sharing dialog. Here you can share the job both with Rescale support or with a colleague. So in this case, for example, I can share this job with Sarah, and I can leave a message here. And when I share this job, Sarah will get an email with a link pointing towards this job, and she can then open this job in read-only mode. She can monitor the job, download the output files, etc. The second The second thing that I want to talk about is the clone functionality that we have built in. This allows the user to clone the setup of the current job. So if I click this clone button, I get an exact clone of the setup of this job. The job will have the same name, except it has this cloned at the end of the title. But other than that, the job is set up exactly the same. And now, for example, I can make small changes, for example, to the job if I would like to. I can, for example, edit my input file right here in the browser. Say, for example, I want to change the, let's say I want to change the termination time. I want to lengthen it to say 0.2 seconds. I would change that value and then save it. And then I could go ahead and resubmit this job. And this provides a very streamlined way of setting up jobs that are very similar to other jobs that you've submitted. So let's now go back to our original example job. There's some other things here on the page that we could go over. One is the chat functionality. So here we can chat with a Reskill engineer. This allows you to get real quick access to support. Say, you've got a question about the specific status of the job, or there's something that you don't understand on the status page. You can go ahead and use this chat functionality to contact Reskill support directly. A last way of contacting Reskill support is to just email us at support@reskill.com, and we'll usually get back to you within 24 hours. So looks like that our servers have started, and our files are now being transferred to the server and being decrypted. Once your cluster has started, you're presented with this live tailing interface. And this will allow you to look at all the files that are currently on the cluster. This is very useful if you want to monitor the status of your job. So for example, we can go ahead and look at the log files. Each job will have the process output.log, and this is the log from our wrapper script, our command line interface that we wrote. And it gives you some information on how we are submitting the job to the cluster. So in this case, you can see that we're running on 36 MPI ranks. We're using platform MPI. Gives us the location of MPI run. It tells us the precision, the parallelization type, the version that we're using, and then it will also actually show the full command that it's submitting to the cluster as well. Then we also have the LSDyna log. This will give you the output of LSDyna itself. So here you can see the output. This is probably very familiar to all the existing LSDyna users out there. And so during the time that the job is running, you can always come back to the status page and look at the status of your job through these logs. Lastly, here at the bottom, there's some information about the cluster status itself. This status gets updated every 5 minutes, and it will give you some information about the CPU utilization as well as the memory, the disk space, and the network usage. So this is basically the user experience on Reskill for monitoring your job. So let me now go to a finished job. So here's a finished job that I ran last night. And once the job is finished, your files will be encrypted and uploaded to the persistent data store. And you can browse your files right here from the user interface. So for example, I can search for log files again here and take a look at the LSDyna.log and get some information, see that my job has terminated normally. We can download individual files by downloading them here. We can also select multiple files and then perform some bulk actions on those files, like deleting them or downloading them. And then lastly, you can download the files, download all the files in a single zip archive by using this blue download button at the top. We've got a couple other download options as well. We've got a command line interface tool that you can use for those who are comfortable with using the terminal, whether it's on Linux or on Windows. We also have a native app for Windows, a download manager, which allows you to download your files in a multi-threaded manner. All right, so that's the overall experience of running a job on Reskill. So what I want to go over now a little bit is some extra functionality in our command line interface. So like I said before, or talked about before, is the ability to run, for example, SMP or hybrid versions of LSDyna. So I've got a job here that I ran before. And if you go to the setup of this job, we can see that I passed in this this extra flag for the number of threads used per MPI rank. And this will automatically calculate the right number of MPI ranks to run, as well as setting up OpenMP to use the correct number of threads. So when we go look at the logs, we can actually see that that we're using the hybrid version of LSDyna here. And so that's a way you can use, you can run hybrid LSDyna simulations on Reskill. Similarly, you can run pure SMP simulations as well. I will just real quickly show you the command to use for that. So in this case, I'm passing in, instead of the number, 2 as the number of threads, I'm actually using the number of cores per node here to run in pure SMP mode. So lastly, what I want to show you is how to bring your own version. I will show you a high-level way of how to set up your job. If you have any more questions about bringing your own version, we would be happy to help you out running your own version of LS Dyna. But I'll give you a high-level overview here. So this is the same model setup that I've used before. Only in this case, I've uploaded my binary here. And this is version 6.1.0 running Platform MPI. So this is a version that we don't have yet installed on Rescale. For that reason, we bring our own version. We just downloaded it from the LS Dyna FTP site, and we selected custom versions / revision from our version drop-down menu. And in this case, we specified a version here to use, which is 6.1.0 Platform MPI, and the precision, which is double precision. And so that's all you really have to do to run your own version on Rescale. So it's really pretty easy to set up. More information on bringing your own version can also be found at support.rescale.com on our support site. So I want to next talk a little bit about post-processing. We have a feature available on Rescale called Desktops. This allows you to launch a Windows desktop on Rescale. I've already got one running here, but I will quickly show you the setup. I can select my configuration here on the setup page, and then I can give the desktop a name. And then I can just launch my desktop here. And then you're pretty much brought to a similar status page, which will go ahead and provision your desktop. Once your desktop becomes available, you can generate your password here and download the RDP file to log into your desktop. You can also select the software you want to use, say LSP Post, and jobs that you want to attach to your desktop. Say I want to add this job here to my desktop, and then I can go ahead and sync that desktop. However, I already have this desktop here running that already has this loaded, the jobs loaded, and so here is the RDP session that I've opened. So I got LSP Post here on the desktop. I can go ahead and open that, and then open the job that I have attached to my desktop. So on the desktop, there's a folder called Attached Jobs, and I've got this Caravan model here, and here are my output files. So I can just load this model here on the desktop. I can go ahead and kind of like move this model around, play the model. So that's the desktop feature here on Rescale. And so with that, this concludes my demo of the Rescale platform. I'm running LS-DYNA simulations on Rescale. Lastly, I want to just talk real quick a little bit about some of the scaling on Rescale. So let's go back to the presentation. So as I mentioned before, we've got many different core types and hardware options on Rescale, including the latest Haswell processors, as well as InfiniBand and 10 gigabit Ethernet. So here are some scaling numbers for the LS-DYNA Caravan model that we just ran. This is a 2.5 million element model. So the top line here is Onyx. This is the perfect scaling line. Onyx is Haswell, so that's why it's got the steeper slope for the ideal scaling. Onyx is a 2.9 gigahertz Haswell Xeon processor. It also has 10 gigabyte Ethernet interconnect. So the scaling is not quite as good as our InfiniBand core types. So you'll see a little bit faster drop-off here relative to the ideal scaling. Then we have Ivory and Copper, which are both InfiniBand core types. Copper is 2.5 gigahertz Ivy Bridge processor. And Ivory is a slightly faster 2.7 gigahertz processor, but it's the older Sandy Bridge Xeon processor. The difference is fairly minimal here. The older Xeon processor performs a little bit better here because it has a higher clock speed. Lastly, I want to mention that our Haswell processors do have AVX2 instruction sets, so we can make use of AVX2, which allows us, a lot of the simulations to run significantly faster, up to 20% faster, given the same clock speed. So that's a little bit of our of the scaling numbers, and I'll hand it over to Sarah.
Okay. So that actually concludes the presentation portion of the webinar. We're going to move to questions. We did receive a handful of questions that we want to get to. Some of these I think were answered in Moyanto's presentation, but a couple people have asked whether or not this is being recorded, as they missed the beginning. It has been recorded. We'll be sending this out either later today or tomorrow to everyone who registered and attended the webinar. So you'll be getting that. Let me take a look at some of these other questions. One of the questions, Moyanto, if you want to address this, is how often we're upgrading processors on the cloud.
We are upgrading processors as soon as our cloud, our cloud partners update their hardware. This is generally multiple times a year. For example, in the coming year, we'll have the latest Broadwell processors coming online on Rescale, as well as new GPU core types as well.
And Moyanto, if you want to take a look at this question, this is for you.
So the question is, can you review D3 plot simulations while the job is running, as well as being able to stop the simulation and enter in commands. So we do allow the user to SSH into the cluster. You'll have to set up SSH into the cluster. We have documentation on that on support.reskill.com. Regarding looking at DSVPlot files while the job is running, you can hook up a running job to our desktops feature that I showed. So you can actually hook into the shared directory of the job that's running and view the DSVPlot in a similar manner that I showed you in the demo.
Okay, here's another one, Alastana specific.
Yeah, so here's another question about sending switch signals to Alastana. So yeah, you can SSH into the cluster to send switch signals to Alastana.
And the next question is, how easy is it to run jobs in batch? For example, can we submit 50 jobs at once?
Yeah, you can definitely submit an indefinite number of jobs at once. There's several ways of doing that. You can create individual jobs. You can also use our DOE framework to submit 50 different jobs that are very similar, so you can run parameter sweeps. Some of our customers use this functionality to run their big parameter sweep jobs. You can also use a command line interface to submit jobs straight from your desktop using the terminal, whether it's PowerShell or DOS, or whether it's your Linux terminal.
Okay, and I think I can grab the last few questions we have here. Someone has asked whether or not they can use the Rescale license or that they must have Alastana licenses to run. There is a requirement from LSTC that to run on demand on Rescale, users must have a single core license internally or a local license to then run. You can be leasing that single core month to month, but that is a requirement from LSTC to run on Rescale. I've also had a question around pricing. I'm happy to talk with anyone interested offline about Alastana on-demand pricing, as well as if you have specific hardware pricing. Obviously, with the different hardware configurations we have, the pricing varies across those, so we can address that offline as well. And another question we have here is someone has asked if they have unlimited Alastana licenses in-house, if they can run those on Rescale. It is possible to bring your own license for Alastana to Rescale with a VPN option. So if anyone is interested and has sufficient licensing that they want to run on Rescale, the VPN is a way we can connect to your licenses so you can run those. So again, these are questions we can set up sessions offline to talk about. The last couple questions we have here is accessing hardware at one of our dedicated sites in Europe or Japan and how to do that. You would log into that specific platform. So as an example for Europe, it's eu.platform.com, which is eu.rescale.com, I'm sorry. And it's the exact same interface, but it is, again, regionally located within Europe. And also our final question here is it possible to run a trial? The answer to this is yes. Many of our customers want to try out Rescale before committing to the transition. You can contact us directly and we can set you up. If you're looking for an Alastana specific trial, as long as you're an existing Alastana customer, we can work with LSTC to enable you with a short trial of Alastana as well. So the last couple slides here to finish up. All attendees for this webinar will receive $50 in Rescale hardware credit. You can sign up for an account here or email us directly with this webinar code. You can also schedule a one-on-one booking with our team to go through a lot of this again or to ask specific questions you may have. The last note we want to make here is that we're actually going to be at the Alastana conference next month in Michigan. I'll be there personally along with one of my colleagues. You should stop by our booth and say hi. We're also going to be having a raffle with an exciting giveaway, so we hope that we can see you there. We want to thank everyone for attending this webinar today. If you have any additional questions, feel free to reach out to us directly, and hope you all have a great day.